Kia ora 13 MCA. This video is going to go over a question from Henry on his way out the door today, which was just asking me again about the horizontal shift. And I think, Henry, this is what you meant. If it's not what you were after, then send me an email and I'll do a different video. But I wanted to have just one more go at making sure everyone knows how to get the equation from a graph. So a couple of places we've seen this come up. We saw this come up in the practice tasks 1 and 2 where you had red and blue graphs, right? And so you were told one function and you had to figure out the other function, and then we had to do stuff like, I don't know, say where the function was higher than that, or we might have had a second function. Now we've got a big mess, right? So anyway, we might know this equation here, but we might have to work out the green equation. So what I want to do in this video is I'm going to go really slowly through the horizontal shift stuff, but I'm going to do the other graphical features along the way. Now from class today, I got a sense that most of you were pretty good with this, but the horizontal shift can be a bit of a pain. I want to show you that sometimes, well, there's always more than one way to do it. And so I'm going to do 2 examples, but for each example, I'm going to do 4 different functional forms. So I'm going to do 2 sine functional forms, and I'm going to do 2 cosines. And what I'm doing with the choice of those is showing you that it depends on where we think of our starting point. So for the 2 cosines, when I'm looking at the horizontal shift, the first obvious one is to start here, right? So what I'm trying to do is figure out what that is. And that's because the cosine curve looks like that, right? And so then for the second cosine curve, I've also got a maximum out here. And so I could do the horizontal shift being all this way out. Okay, so the cosine one's pretty easy. The one where it's easier to muck up is if you're trying to model it with a sine curve. And so for a sine curve, what we've got to do is remember that, oh, very bad drawing. Sine curve starts here. So I'm looking for this point on the graph. And so this point is just a little bit more work to find. I've got that one there and that one there, so I need to find the point halfway between A and F, right? So I'm basically looking for this point here. But I could also model that, so that would be my horizontal shift there. Or I could model it out here by finding the starting point. I'm trying to see where the halfway, oh, the halfway point is here on 0, right? Oh, sorry, guys, it's been a bit of a long day. So there's my halfway point there. But obviously when you've got vertical shift and different stuff going on, it's not always going to be that obvious. So Henry, that might be enough for you, but for other people watching, I'm just going to go through it really, really slowly. So first up, we're going to look at this example where there's no vertical shift. And that makes the numbers just come out slightly more easily. Then the next one I'm going to do is one where I've got a vertical shift going on and a change in the period from the usual 2 pi. Okay, so we're 3 minutes in and I haven't actually done any maths yet. Let's look at what our functional form is, just for the 5,000th time. So we've got y is equal to a cos of b times x plus c plus d. Right, a is the amplitude, d is the vertical shift, b is the frequency, which is 2 pi over the period, and c in here is the horizontal shift. So I'm going to do a, b, and d first, and I'm going to do them pretty quickly. So let's go back. Yeah, let's look at this first one here. The midline is the average of 4 and negative 4, which is 0. So there's no vertical shift. The amplitude is 4 take away 0, which is just 4, so that's A. Right, the next thing we're going to work out is the period, and I'm going to do it from the coordinates. Right, so 1 full cycle here. I could go from here to here, or I could go from here to here. I'm picking these 2 because they're positive numbers. So the period here is 7.32 minus 1.043, which is 6.276, which is roughly equal to 2 pi. Okay, so the frequency is just 1, right? So frequency is the usual period of the cosine or sine function divided by this period, which is 1. So b is equal to 1. Right, now we're doing a cosine curve here, so the horizontal shift in this case is super easy to figure out. Right, we're going to start here. Where is that point? Well, we need the x coordinate of that. It's just 1.043. Now, it'd be nice to get that as a fraction of pi. So let's have a look at 1.043 divided by pi is roughly equal to 0.3321, which is close enough to 1/3, right? Remember, all of these numbers are rounded because I've just grabbed them off my calculator. So that tells me that my horizontal shift at 1.043 is equal to pi on 3. So that's my starting point there. And look, that looks about right from the scale on my graph. So my equation for that is that y is equal to 4 cos of x minus pi on 3, right? So that's cosine model 1. Let's do very quickly cosine model 2. I don't know why you do this, but I'm just trying to make the point that you have got lots of choices about how you link up your equation and your graphical features. So suppose for some weirdo reason that I wanted to make that the starting point of my cosine curve, then my equation would be the same thing. So it would be y is equal to 4 cosine of, what have I got here? X minus, now this number here, we're going to go 7.32. 7.32 over what? Let's see. 7.32 over pi, to work out what fraction it is equal to 2 1/3, which is 7/3, 7 over 3. Now, I can feel some of you screaming at me down the computer, of course it's 7 pi over 3, miss, right? Yeah, and of course it is, right? Because this one here was pi over 3, and the period of that function is 2 pi, right? So when we add the 2 pi and the pi on 3, we get 7 pi on 3. Right, but I'm just trying to show you you've got choices. So then next I'm going to do it as a sine curve. And there are a couple of ways to go here, but I think the easiest way to go is to think about where the starting point of that sine curve is. And I've done this in my old trig modeling video, but here's my minimum point of the curve, and here's my maximum point of the curve. Thinking about your ordinary sine curve, there it is there. This is my starting point. So I'm trying to figure out where that is. Now in here, that's pretty easy to find. It's at that point there. So if you've got this on your graphics calculator and you haven't got a vertical shift, I just thought of this, you can find this point by finding the roots, right? You can look for that root in there. But if you have a more complicated function, that's not going to work. So what you're looking for is halfway between those two coordinates is going to be the coordinate of that one there. So let's figure that out now. So this coordinate is going to be negative 2.099 plus 1.043 divided by 2. Call that point, I don't know, call that point C. And that gives me negative 0.528. Right, and we want to get that as a fraction of pi. So we look at it compared to pi and we get negative 0.528 over pi is roughly equal to negative 0.168, which is roughly equal to 1/6. So the shift here is going to be that direction, pi on 6 units. So that means to write this function as a cosine function, it's going to be y is equal to 4 sine of x plus pi on 6. So there's your horizontal shift in a sine model. Okay, and I could do the same thing, moving out 2 pi units. There it is again there. Right, so I'm going to take the midpoint of those two numbers, and that's what I'm going to have there. And so we know that it's going to be 2 pi added onto that one. So I've already used up 9.5 minutes, and I haven't got to the hard example. So actually, I'm not going to do the second sine function in detail. I'm just going to hop to the answer that we could also model that as 4 sine of x minus 11 pi on 6, right? And you can see the period of the function coming through in there. Okay, let's move on and look at the slightly harder one. I'm hoping that you guys are going to be good with doing the features of that, but in this one, the first thing we do is we look at the midline. The midline is 4 plus negative 2 over 2, which is 1, so it's got a vertical shift of 1. And we can whack that onto the graph, because that's going to help me see where the midpoint is. What's next? So that is my D, and my amplitude is going to be 4 minus 1, which is 3, so that's A. So let's model this as a cosine curve first. So we're doing that. What else do we need to find? Well, we need to look at the period of the function. So the period of the function is not going to be 2 pi. One cycle, or I could use those two there, one cycle will be 2.881 minus 0.785. So you can see it's something a bit funny with this one here. What do we get? We get 2.096. So I need to figure out what. So that's the period of the function. So the frequency is 2 pi, the normal period, over the period for this function, which is 2.998, which is roughly 3. So we've got A, we've got D, and that's equal to B. So the only thing we've got left to get in here is the horizontal shift. So far we're up to this. We've got y equals 3, sorry guys, dog's about to start making noises. 3, what am I doing? I'm doing cosine, right? 3 cosine 3 times x something something plus 1. Right, now when I'm doing cosine, the horizontal shift is so easy. It's just going to be here. That's my starting point. And we can look at 0.785. Let's do it as a fraction of pi. A couple of ways to do that. We can figure that out. I'm just looking at my piece of paper so I don't get any numbers wrong. So 0.785 divided by pi is equal to, I'll just pause the. Okay, sorry, I was having a complete brain freezing moment. So that's equal to 1/4, right? So the horizontal shift in here is just pi on 4 units. There we go. So that's the easiest way to do that, right? But if you were doing one where you had to model it as a sine curve for some weird reason, what would we do? Well, we've got a couple of choices. But the easiest way to do this is to find the halfway point on that sine curve, to look for the starting point. So we're starting, here's the bottom here, here's the top here. This is going to be my horizontal shift. So that's the number that I've got to find. That horizontal shift will be the halfway mark between H and I. So I'm going to do that quickly now. So it's going to be 0.785 plus negative 0.263 divided by 2. So the midpoint of those two, or the x coordinate of the midpoint. And that works out to be, I think, hang on, 0.261. Right, and if we're looking at that, we get 0.261 divided by pi is equal to 1/12. So my horizontal shift in there, and you can see that that looks about right, is going to be very small. So that point there is 0.261, and that's equal to pi on 12. Right? So when we go to put that all together in the equation works out to be y equals 3 sine of 3 times x minus pi on 12 plus 1. I'm just checking that I've done that right. I'm sure one of you is going to email me immediately and tell me if it's wrong. Okay, but I think that's right. So you can see that that all washes out in here. When we put in x equals pi on 12, this will go to 0. This will be 0. And so this whole thing will be 0. And this will be my starting point of 1, right? So that's why we're ending up here. So that's doing it with a sine curve. So as I said, if you've got the choice, and I've said this in class, then do it with a cosine curve. But Henry, you were wanting to know about horizontal shift, so I think that's about all there is to say. Please, guys, if you've got questions about this one, I know it's pretty long and waffly, but just flick me an email and I can do another video to help.